yeah, welcome back, everyone. Well done if you did session one. I know there was a lot of replays of it, which is great to see as well. So now we are heading into Building on Algorand, All You Need to Know, Technical Workshop 2. And before we get started straight away, some of you may have done the homework last time, getting AlgoKit ready, but in the chat, if you have not got AlgoKit ready, as we will once again, you'll have the option to use CodeSpace where you don't need a setup at all, but we recommend you do get your local environment ready. So in the chat is a link to get AlgoKit. It's all free and it's easy to set up, I promise. But yeah, let's get stuck into our presentation. So Camilo already went through this, so we'll continue moving on. So today we'll be covering three main things. I call it the three W's, the what, the why, and the when. So what is a smart contract? Why use a smart contract? And when you should use a smart contract, because you don't always need to use one, especially with Algorand. And then building on the AVM, the Algorand Virtual Machine. So I call them the secret sauces. We'll look at an approval and clear state program, global and local state storage, and box storage basics. Lastly, we'll be getting on to the big chunk of this workshop, developing smart contracts. But we're taking a more conceptual approach, so it's not just looking straight at a smart contract, because that can be quite intimidating, and this is welcome for everyone, for beginners as well. So we'll be planning a smart contract with Miro, and then start in our local environment, or you can use CodeSpace, and then building a smart contract with AlgoKit, we'll be doing a digital marketplace, which some of you who have been here for a while, some OGs, might have done the boot camps where the DevRel team went through the NFT marketplace. So yeah, this is the agenda. So smart contracts, the what, why, and when of smart contracts. Firstly, what is a smart contract? So a smart contract is a self-executing program on a blockchain that automatically enforces and executes the terms of an agreement. It automates processes, reduces the need for intermediaries, and ensures that agreements are executed exactly as programmed without manual intervention. So if we were to think of it a little bit deeper, a smart contract is like a regular contract, but instead of being like written on paper, it's written in code and deployed on a blockchain. Once it's deployed, it self-executes when predefined conditions are met. And this eliminates the need for intermediaries like banks, lawyers, or agents. For example, a common use case is automatically releasing a payment for, let's say, a product once its delivery is confirmed. This removes delays and ensures fairness between parties. The key takeaways of a smart contract is automation, security, and trust. These are at the heart of smart contracts. So I guess if we were to dive into smart contracts, we should ask the question, why use a smart contract? And we have alluded to some reasons above, but let's get into some more. So why use a smart contract? Firstly, streamline transactions. Traditional agreements require paperwork, approvals, and third parties, which can take days or weeks. You know, maybe on a bank holiday Monday, they're closed, or, you know, on the weekends, banks are closed. So smart contracts can execute in seconds. It's lower cost, so by cutting out intermediaries, you reduce fees. For example, local legal fees or broker commissions can be avoided. And there is an increased security. So obviously, if you have somebody being an intermediary, they have to look after everything and you put your trust in them. And of course, there can be human error, which is okay. Smart contracts are nearly impossible to alter or tamper with, of course, if they're built with the utmost caution. And this ensures the integrity of an agreement. So imagine a scenario where Alice wants to sell her house to Bob. Traditionally, this process involves multiple parties, you know, real estate agents, lawyers, and banks, each taking a cut and adding delays. With a smart contract on a blockchain, Alice can create a contract that automatically transfers ownership of the house to Bob once specific conditions are met. such as a payment confirmation. Once Bob sends the agreed upon payment to the smart contract, it automatically verifies the transaction and updates the property records without needing a middleman. This not only speeds up the transaction and the agreement, but also saves both parties money by eliminating fees associated with agents and lawyers. You could also think the same way for events. So Ticketmaster is a huge one, and that takes service fees, or even booking online for your cinema ticket or bus ticket, which I see quite a lot. So in this way, smart contracts provide a secure, transparent, and efficient alternative to traditional agreements, ensuring everyone fulfills their part of the deal without the usual hassles. So it sounds kind of like magic. It sounds perfect, right? But when should you use a smart contract? It's not always necessary. It's important to remember that smart contracts aren't required for every transaction. Algorand, for example, offers atomic transfers, where group transactions, where either all the conditions succeed or all fail. This can cover many use cases without needing a smart contract, like we explored in Workshop 1. So if you haven't gone through Workshop 1, I advise it. It's what you can do without using a smart contract can be very handy and a lot easier. It can save a lot of costs as well for your project idea, because of course this is for a hackathon as well. You don't always need a smart contract. You also need to be risk aware. Smart contracts are written in code, so coding errors or vulnerabilities can pose risks. Once a smart contract is deployed, it cannot be changed. You may update it, but that will change the application ID, of course. We'll see later. So any flaws in the code can have serious consequences. This is why auditing and testing are critical before deploying. And my advice personally as well is to deploy locally in your local private network, which we'll be playing with later, then testnet, and then of course after audits or other ways to make sure your smart contracts are secure, then uploading to mainnet. So some use cases. There's escrow services, a common use case for smart contracts, for example, holding payment in escrow until certain conditions are met, such as delivering goods, which guarantees trust between buyer and seller. There's also voting systems. So when transparency and security are critical, smart contracts ensure that votes are securely cast and results are tamper-proof. Insurance claims, automating claim approval and payout based on predefined events, speeding up the process and removing human bias. And another big one, tokenization of real-world assets. Smart contracts can handle fractional ownership of physical assets, like real estate, which we've seen in Workshop 1, we looked at Lofty, making it easier to manage ownership and trades in a secure, transparent way. Of course, there's other ones on that presentation as well, like royalties. So lots of times when you should use a smart contract. So now if we take a little look at building on the AVM, we're going to dive into some of the powerful capabilities you can leverage with Algorand, but I'll really quickly check the chat. Please feel free to put questions in the tab. My good friend and colleague Camilo will be monitoring those. But yeah, we'll continue for the next part of the presentation. Perfect. So I want to talk to you today about approval and clear state programs. This is getting a little deeper into it, but this is the next step. If you're going to start using smart contracts, you should know what's happening. And so in the approval program, this is for Algorand smart contracts. The approval program is the backbone of regular user interactions with a smart contract. Anytime a user interacts with a smart contract, for example, transferring the assets, opting in, or performing an operation, the approval program is triggered in the process to process the logic behind these transactions. Approval program can also read and write both global state, which is shared across all users, and local state, which is unique to individual users, which we'll learn about soon. So don't worry about that. Think of approval program as the program that enforces the rules of the smart contract, ensuring all actions follow the contract's logic. It's the core logic of the contract. Our clear state program is different. Its role is to manage forced opt-outs from a smart contract. When a user wants to leave or exit the contract, but didn't go through the proper opt-out process, perhaps maybe when the developer was building the smart contract, they never gave that option. But of course, just thinking of it, if you go into a smart contract, you don't want to be stuck inside of that smart contract. So the clear state program kicks in at that point. So it allows you to exit. You'll never be stuck inside of a smart contract. Its main job is to clear any local state that the user had within the contract. However, this is more of a fallback mechanism. It's not meant to be the usual way to leave a contract. So the developer should always, or it's recommended you always have a way to opt out of a smart contract. The key takeaway is the approval program is for day-to-day interactions, and the clear state is more of a safety net for when things don't go as planned. Now, here's the really good news. Since we have AlgoKit, when you build a smart contract using AlgoKit, it simplifies the entire process. It automatically generates the artifacts folder, which we'll see later. So if this is all completely new to you, don't worry. We'll have a look at everything and it will start to make sense. But these artifacts folder contains both the approval program and the clear state program. This helps streamline the development as you don't have to manually create or manage these files. They are automatically generated for you and they are ready to go as soon as the contract is built. So you might have seen I mentioned global and local state in the last slide, but what exactly are they? So global state in Algorand is where the contract stores application-wide data. This data is accessible to all users and even other smart contracts, making it similar to a public ledger. You can store up to 64 key value pairs in the global state, and it's saved on the creator's account. But important, this data is publicly visible. Anyone can see it, okay? For example, let's say we're building a voting system. The global state will act like a public scoreboard, so it's out for everyone to see. It keeps track of the total votes for each candidate. For instance, candidate A has 10 votes and candidate B has 5 votes. And say like in the football games or any sports that are very popular, has a big scoreboard, and anyone on the blockchain can view this tally, ensuring transparency and trust. Local state, on the other hand, the local state holds user-specific data. Each user can store up to 16 key value pairs on their account, but they have to opt in to the smart contract to use this local state. Also, just a side note, I wouldn't worry too much about the numbers of how much they can store right now. This is obviously a beginner workshop, but as you go further, you may want to know these types of numbers. A key feature of local state is that the user can clear their local data whenever they want, meaning they have control over their personal interactions with the contract. So, for example, if we continue with our voting system analogy, the local state acts as a personal notebook for each voter. So we have the global state with our big scoreboard, 10 votes, 5 votes, and we have our local state. If Alice votes for, let's say, candidate A, her local state will reflect that choice. And if Alice decides she no longer wants to participate, she can clear her local state, removing her vote from the system. Really quickly, we mentioned in local state that they have to opt into the smart contract to use the local state. So I'd like to say why opt-in matters. So users must actively opt in to interact with the smart contract, which means they have agency over whether they participate. This makes local state highly personalized and secure for each user's data. Okay, this is a lot of information, but to sum it up, the global state is like a shared public scoreboard. Everyone can see it, and it applies to the entire application. The local state is more of a personal notebook specific to each user. It's private and requires the user to opt in and can only be cleared at any time. Perfect. I have one more slide about the AVM secret sauces, but I also have some links I'm going to share, which I thought were very handy learning about this type of thing as well. But if we talk about the last bit of storage, we have obviously 3 storages on Algorand: global, local state, and box storage. So with the box storage capacity in Algorand, box storage allows each box to hold up to 32 kilobytes of data, which translates to 32,768 bytes, which is very specific. This is enough capacity to store substantial information for various use cases. You probably won't need to know that number because you may not even reach it. One of the powerful features of box storage is that applications can create unlimited boxes. This makes it highly scalable, but of course, there's a catch. Each box storage has to be funded by the application account. So while the number of boxes is unlimited, the more boxes you use, the more resources you'll need to allocate, of course. Another crucial aspect is that the data in these boxes is secure. Other smart contracts cannot access it, ensuring privacy and isolation of application data. So with the data access, each box allows 1024 input-output accesses per reference, meaning you can read and write data 1024 times per interaction with a box. You can also use up to 8 references in a single transaction, which allows for efficient data management when working with multiple boxes or large data sets. So if we combine multiple references in a single transaction, you can handle larger or more complex data sets efficiently without needing multiple transactions to get the job done. That's a lot of numbers and a lot of information. So if we bring it to a real world scenario to make it more practical, let's imagine a developer is building a platform for buying and selling tokenized real estate. Every property on the platform has a detailed set of records: ownership history, legal documents, and even maintenance logs. There could be more as well. But this is a lot of data to manage for each property, especially if you're a billion-dollar company. Using Algorand's box storage, the developer can store each property's records in separate boxes. And of course, they're unlimited, so you won't get stopped in your tracks. This ensures that the data is well organized and secure, and each box stores all the information related to one property. And as more properties are added, new boxes are created to handle the additional data. Because each box is independent, the platform can scale seamlessly as the number of property grows, keeping the data accessible and well structured without risking the integrity or security of the records. It's always important to ask the question why. Like, why should you use this over this? Of course, that was a good example, but why does it matter? So the flexibility and scalability are vital, really critical for building complex real-world applications without needing to worry about the limits of storage. Developers can focus on creating efficient and scalable solutions, whether that's real estate, supply chain management, or any other data-heavy application. These past few slides have introduced the core capabilities of the Algorand Virtual Machine, or as I've been calling it as well, the AVM secret sauces. from how smart contracts interact with user and application data through approval and clear state programs, to managing information at both a global and local level, and finally leveraging block storage for scalable, secure data handling. All of these elements work together to make the AVM incredibly powerful for building decentralized applications. So it's really good if you leverage that, of course. It'll make the job easier for you in the long run. And if you want to take a deeper dive into the AVM or perhaps review some of these topics, I recommend this playlist from the AlgoDevs YouTube channel, which I'll share into the chat. So in the chat, I've just sent the link to the AlgoDevs AVM Explained series. It's really good. It goes through, of course, even more than what I've just went through. But if you're looking to revise with more content, because how people explain things is different every time, so you may pick up some more meaningful information. So I definitely recommend that. We also, of course, have the developer portal, which is good information, and it is being upgraded, updated as we speak as well. So definitely keep an eye out for that too. Okay, great. Oh, and also another thing I would like to mention is our Discord is full of algo devs. So if a question pops up in your head at like 1 a.m. in the middle of the night and you're about to go to sleep and you can't get it off your mind, I really recommend popping it in there so you can get some sleep as well. So let me get that link really quickly. Algorand Discord. Oh, perfect. Thank you, Camilla. Okay, great. So the next part is planning our smart contract. So we're going to take a look conceptually at how we're going to plan the smart contract. So I will go over to Miro, and you guys don't have to go to Miro. I have it all set up for us, but it will be engaging. So I hope you guys have been engaging in the chat as well. And then after this, I have an all you need to know sheet with the instructions for the coding. We have the code already, of course. It's more so to make sure if you're on the local or code space, what commands you need to use to maybe start localnet, or making sure you have all the dependencies. So I will put that in the chat, but we won't be going to that right now. But I'll put it in the chat, and then we'll also probably revisit that right as we go into that one. But yeah, let's go over to Miro now and take out our whiteboard and become computer scientists. So if I share this tab, hopefully, let me just check we can see it. Perfect. Okay, so now we're going to do our digital marketplace smart contract. And what I'd first like to take you to is the imports that we're going to use in the code. So some of the imports include the asset, global, transaction, uint64, arc4, group transaction, and inner transaction. And that may sound all a little bit mad at the moment, but it's okay. We're going to learn about them. And really quickly, I think it's just nice to know what it looks like in code, so it's not, so much information. Some of you may already have Python experience or blockchain developer experience, but this is just where we're going to import from AlgoPy the above. So let's go through each one. So the asset import represents an Algorand standard asset, which we messed around with in our technical workshop 1. And an ASA is a token on the Algorand blockchain. The asset class provides methods to interact with ASAs, including creating new assets, transferring tokens between accounts, and querying asset-specific information like balances and metadata. It streamlines the management for ASAs within smart contracts. So this is why we import asset. The next one we have is global, which we've taken a look at in our presentation as well. But global refers to global properties or state on the Algorand blockchain, such as the current round, total number of transactions, or other network-wide parameters. This is useful when your smart contract needs to interact with or read global state variables. Next is transaction, which represents a single transaction object. It holds information about the current transaction being processed, such as the sender, receiver, amount, and asset details. Next, uint64, which obviously sounds a bit funny, but it's just a data type that represents an unsigned 64-bit integer. It's commonly used in Algorand smart contracts for handling numbers, and it's very useful when working with variables like balances, amounts, or counters. It's just a data type. Next is arg4. So arg4 is an Algorand request for comment. It is a standard. All args are standards. Maybe if you have been in the ecosystem for a while, you may have heard of different args for like NFTs. But args are a wide different standards in the Algorand ecosystem. So the arg4 is related to certain behaviors or features in Algorand smart contracts. Next, we have group transaction, or GTXN, which refers to group transaction, which allows you to bundle multiple transactions together in a single atomic unit. The group transaction object lets you access and interact with the transactions in this group. And lastly, are inner transactions. What are inner transactions? So inner transactions are transactions initiated from within a smart contract. So that means the smart contract is doing a transaction. The inner transaction object allows you to create, submit, and interact with these inner transactions while the smart contract is being executed. And to have another look in code, this is how we import it. Next, I have a really fun thing that I'd love to test out with you guys. So I'll be back and forth in the chat, but we're building a digital marketplace smart contract. So what do you think is the first thing we need to do if we're creating an application? And there's a hint in there. So see if there's any guesses in the chat. If we're creating an application, what methods do we need to make for the digital marketplace? I'll give it 1 second while I get some water. Perfect. That is completely correct, the create method. So let's do it. Let's start to implement our first one. So if we go here and so we keep an eye on it, create app. Then let's see, I'll grab another sticky note. So inside of this create app, what are some things we need to define? So of course, we need to define the initial conditions when an application is created. So define initial conditions when app is created. And don't mind my spellings. So when we define the initial conditions when the app is created and we're doing a digital marketplace, now this is a basic one, okay? So it's not going to go into every single thing, but the basic things. If we have a marketplace, we obviously have something we want to sell, and we need a price for what we're selling. So we have our asset ID and our unitary price. So our asset ID of what we're selling in our digital marketplace and the price of that asset. If I was to just go into a little deeper of what is both of those things, because it's much easier if we go through it conceptually first, so we think about it, because then we do all the hard work. And then when we go to the code, it'll be much easier, and it's not just like looking at a foreign language. So if I really quickly go to just to make sure we're not losing out on any time, but we have plenty of time. But I'll just paste in here. So an asset ID is a unique identifier for ASAs, And in this instance, it links the contract to a specific asset, allowing the application to track transfers, opt-in, and ownership of the asset. And of course, you can create these ASAs. Well, some great UI out there where you can create it where you don't even have to touch code. But then there's also, you can code it yourself without even touching a smart contract and make it in a Python script, like we did in workshop 1. And then we obviously have our unitary price. So what is that as well? So the unitary price refers to the price per unit of the asset set at the time of the application creation. So when we create the application, we have our initial conditions, asset ID and unitary price, and we set a price for the asset at the application creation. And this unitary price of n currency, so that just means any currency, is what the buyer must pay for each asset unit. Okay, so I think that's pretty clear about creating the application. But now in our next one, can anyone guess what we have to do? So we create the application, and now we need to work on our asset. So what are we going to do in the next one? If there's any guesses, I'll give you a bit of a clue. We talked about it a tiny bit in our unitary price. We have to set something, because of course when you set it at the creation, we're probably going to set it at 0. We'll need to set it on a new price if we're going to try make some money from our marketplace as well. So I'll see if anyone's typing, but I'll keep going. We have to set a price. So the second method that we need to do is set price. And so in this method, what we have to do is basically define the listing price for our assets. And this value is stored in, I would love if somebody gets this right. If we have to define the listing price for our assets, this value is stored in what state? I'll give you a clue. It's either the global or the local state. And this is the price now that you have to do for the asset. So which state is it? I see some people typing. Perfect, yes, both correct. It's the global state, because everyone has to see it, of course. You can't sell something and nobody knows the price of it. So we define the listing price for our assets in the set price method, and that value is stored in the global state. Okay, so we created our application. We have a method that sets the price. Now this one, I probably won't get you to guess. If you guess it, it's really impressive. But this is Algorand specific. So we have our asset, but for the smart contract to interact with the asset, it needs to hold that asset, of course. And to receive an asset, an ASA on Algorand, you need to do something called an opt-in. So the contract must opt in to receive the asset to be sold. So if I get that here, just so it's easier for everyone to see, especially if anyone's tuning in a bit later. So we have the contract must opt in to receive the asset to be sold. And while we do that, we have to make a few checks, or it's also known as assert, make some asserts. So in here, we make some asserts. I'll zoom in. Let me know, by the way, if I need to zoom in at any point. So the asserts we need to make for the contract to be able to opt in is we have to pay for the MBOR. That stands for minimum balance requirement. So of course you can't do anything if your account or smart contract doesn't have any algo, which is the native token of Algorand. So we need a minimum balance of 0.1. And then if we're going to opt into an asset, which makes the assumption we're going to hold that asset at some point, we also need the minimum balance requirement for that as well. Okay, great. And then, of course, the last the last action that should happen in this is, the last action is that the smart contract does the opt-in. Great. So now number 4. We have the asset inside of our smart contract in our digital marketplace. So it's a marketplace, so we hope people buy from it, right? So the next method is buy. And in this method, the buyer user can buy n number of assets, so how many number of assets that were provided, of course. But to do so, they must pay the equivalent price multiplied by the number of assets they want, defined in the set price method. Then in the next part, we have to make some asserts again for the smart contract to make sure that these preconditions are met and everything's working in the way they should. So if I go over here, the asserts we'll have to make for this one is that the price is obviously greater than 0, because what's the point of putting it on a digital marketplace if it's just going to be free? Then you can just send it out. We have to make sure the payment is sent to the application, that the payment is sent to the application quantity equals the price by the quantity. It has to be the correct price, of course. Imagine we had an asset that was worth 5 algo and we paid 2 algo and we still got it. Now, I would probably go to that marketplace a lot, but I don't think they'll be running for very long. And lastly, what we want to happen is that that it does the asset transfer. So once they buy, they should get the asset transfer. All right, I'll just check chat really quick to make sure everything's going okay. Yeah, I see something in the chat saying I was going to say opt in to this asset ID before setting the price. I guess it could go either way, but for this one anyway, we're just going to do set price, then opt in, and then buy. But of course, this is where your creative freedom can take over as well. Alrighty, now there is one more, but it's optional, of course. And you may remember the clear state, where if there was no way to exit a smart contract, there automatically is a clear state, which means that the user will never get caught and just stayed in a smart contract. So the 5th one, if there's any guesses, what is the last method we have to do? It's the delete application. Oh, so if I go back over to Miro, delete app. So for this one, we want to delete the application so we can recover the MBOR of 0.2 algos. If you remember over here, let me get my pen out because this is the cool thing about Miro. Our MBOR over here, we have to recover that. But there are some cases where the balance can be more than that, of course, because if they're buying the assets, there could be maybe 10 algos. So by doing the application delete, we can recover this balance. And lastly, very, very lastly, what should happen after we delete the application is it executes 2 inner transactions to transfer algos and whatever the remaining reminder assets are. So if we look in full now of what our smart contract should do, our digital marketplace, we have our create application where we define our initial conditions like our asset and our unitary price. Next, we set the price of how much we want this asset to be. And of course, you can have it the other way around as well. You can have the ASA opt into it, and then set the price. But in this flow, we have create application, set price, opt in, where the contract must opt in to receive the asset to be sold. And there we have some asserts. I just call them like you're checking, you're making sure this is correct. This is what's meant to, before we move on to our next thing. And then you need to pay for the MBR. And then it does the opt-in. Next is our buy method, where the buyer can buy any amount of assets that was provided, of course. And then they pay the price. And we do some asserts there as well to make sure the price is not zero, doesn't make sense, and that the payment is sent to the application quantity that equals a price multiplied by the quantity. So that's the correct, that you're buying for the correct price. And lastly, to make sure our users can get their MBR, we can delete the application altogether as well. Okay, great. So the next part of this, what I'd like to do is, I'll just double check chat if everyone's okay. Looks good. The next part I'd like to take you guys through is the methods in code. So the whole point of doing this Miro board is so that we can think about it, and it's not just given the code, or, you know, if you think about it, you'll start thinking in the ways of how to do other types of smart contracts that you need to build. But also that when you have the code, it's not just, it can be intimidating, because I want this to be welcoming for beginners as well. So we're doing a divide and conquer strategy. So let's have a look at all these methods that we came up with in code. So in our create application, we basically are setting, well, actually, if we take it at the very top of here with the decorator and the allow actions and create. So this basically defines, get the pen out again. This defines a method that can only be called when this contract is created using a no-op transaction, which is just like the default value. So in our first one, in our allow actions, this allows the method to be called only by no-op transactions. Like I said, it's the default value. Then in our create equal to require, this restricts it to run only during contract creation. So if we get on to our create application method, you can see we have some setting and initializing the variables. So of course we have asset ID set to asset, which we've imported, and unitary price with the UN64 type, data type. This returns nothing. And then we also initialize these variables. So the asset ID stores the ID of the asset for use in the contract, and the unitary price sets the price per unit of the asset. Next, in our set price method, it's nice and small. We obviously have our arc4 decorator, which I'll talk a little bit about at the end of our methods. But in this one, we're setting the price. So we're setting the new unitary price, and this updates the price per asset unit. And only the creator, with our assert, we're checking, only the creator can update the price by checking the sender is the contract creator. And then, of course, we update the unitary price. And this method also returns nothing. It's just setting the new price and checking that the only person that can update this price is the creator of this contract. All right. Next, in our opt-into asset, we have our MB or pay, which is a group transaction. So MB or pay is a payment transaction for the minimum balance, and we have some checks. We have the application is not opted in yet, which is this one. So check the application is not opted in yet because, well, if it's already opted in, great. We also have our payment receiver, which is the application address. And we need to check the payment amount meets the minimum balance. And at the very end of this, it submits an inner transaction to opt into the asset. So in this section, it's an inner transaction, which means it's a transaction that's happening inside of a smart contract. And it may look familiar from workshop 1, how to opt in. We're opting in by sending the asset ID to ourselves with an amount of 0. Okay, perfect. So that's the opt-in to asset. Next, we have our buy method. So for buying an asset, we have our buyer transaction. And this is a payment transaction for purchasing the assets. And we have a few checks. We also have our quantity, which is the quantity of the asset, of course. So our asserts, our checks, that the sender matches the transaction sender. The receiver is the application address. The amount equals the total price, which is the unitary price multiplied by the quantity. And at the very end of this, it submits an inner transaction to transfer the specified quantity of the asset to the buyer. And don't mind this part, this is the next one. All right, just to repeat that again, obviously we have to check that the sender matches the transaction sender. The receiver is the application address because we're sending the assets, and then the amount equals the total price. Next is our optional one, which we had delete application. And you may have noticed we had lots of different decorators throughout each part. And just to talk about that really quickly, the arc4.abi method decorator allows the method to be called by external interactions on the blockchain, such as transactions from other accounts or smart contracts. It defines how the method can be accessed under what conditions. So each method can be called externally, whether that's another account or if it's another smart contract. But to look at the delete method, we have an assert, where only the creator can delete the application, which is quite obvious, right? So we're checking that the sender is the creator address. Next, we have an inner transaction where we submit it to transfer any remaining assets holdings back to the creator, and we close out the application's algo balance, returning it to the creator. So if we're deleting a smart contract, we can't delete it with stuff inside of it, of course. So we have to make sure we send all of that stuff out. So great. So if we look as a whole across the entire thing that we have done together, we can see why do we have these inputs, why they're handy. Then we have our conceptual process of thinking about how to build this digital marketplace, and then taking a look at the byte size of code and going through what's happening inside them. So now it's time for the doing it ourselves. So we're going to jump into AlgoKit now. So let me just check the chat as well. And also, this is an important point to include we have a all you need to know sheet where all the commands are there, which let's see if we can get a link for it really quickly. I have it right here. I'm sure Camilo has it too. Perfect. Thank you. So if you click onto that link, so I'll click onto it as well. Oh, let me refresh here. Okay, let me see if that's sharing. Oh, perfect. Okay, great. So the link we sent into the chat is basically an all you need to know. We have useful resources, commands, and the code. So to quickly run through it before we jump in so everyone knows what's happening. In here, we have our useful resources, and the code is below in here as well. But there's a GitHub repo where I just have the smart contract and the tests because that's all we're going to be working inside of today. But the overall repo of the digital marketplace that's completed is in this link here. It's been taken obviously from the bootcamps. And then once again, join our Discord full of algo devs to see more code, ask questions, and for good vibes. And especially if you have some questions that may be complex. Next, when we go into our developer environment, so I will be going on my local one, but you can use CodeSpace again, of course. I showed in the first workshop how you can go into CodeSpace. Very simple. You go to, I'll show really quickly. So you go to this repo. I'll send the link in the chat as well, but please go onto our pad rise up to get used to working inside of it. But if you go over to the repo, you can enter the code space by just clicking new code space. But I do recommend you fork it before you do it. So if you do any code that you're like, you want to save, if you use code space, it's a premium service from GitHub. So you only have a month and then it deletes it. But if you do some code space work, you get into a forked repo and then you push that to that forked repo, then you still have it, of course. But the code space deletes after every month. So I recommend you fork it. But of course, I recommend downloading AlgoKit. So great. If we go back here, here are some very helpful commands to get you started. I'll be running through each thing as well, so you don't have to start straight away. To initialize our project, we'll use AlgoKit init. It basically pops up like a questionnaire, and afterwards you enter the workspace, which you'll be prompted to do. When your local environment or code space is loaded in, you'll need to get your local net started. The local net is basically just a private Algorand blockchain running on either the code space or your Docker, if you have that set up. And if you're having any local net problems, which may even happen to us today, hopefully not, but it may, then I always recommend doing a AlgoKit local net reset. It's also handy if you want to clean off all the blocks and start new. To build your smart contract and to generate those artifacts folders, we'll use AlgoKit project run build. And if you're having any problems with building your smart contract, I recommend using AlgoKit project bootstrap all. When you init, it will do that for you, but for whatever reason, it's always handy to make sure your dependencies are all installed. Lastly, when we have our tests, we will run AlgoKit project run test. Lastly, we will observe these tests with a beautiful UI from Laura the Explorer with AlgoKit explore. So those are the command line commands. For the code space users, I know in the last session, we kind of went through it very fast to how to go to Laura from the code space. So here I have put in all the different types of ports that you'll need to make from private to public. So once you turn the AlgoD, the KMD, Vite, and indexer to public, then run the command AlgoKit explore, and it will come up. I also have some instructions of where you find the ports in case you're not used to that as well. That's totally fine. And if you're having super intense setup problems, which may happen, but don't let it deter you, to find out what you may be missing in your setup, run AlgoKit doctor, which I'll show that as well. But then I recommend if you are having really lots of setup issues, come to our Discord. And then lastly, we have our code for the smart contract for you to copy and paste in, as well as our tests. Now, of course, we are like an hour deep into our workshop, so we're not going to be going line by line. Also, all this has been done before, and the videos are on AlgoDev's YouTube channel, where the senior devs go through each line of it as well. So I do recommend that as well. So great, so let's actually get started ourselves, and you can follow along with me, or you can just check out our file here. So I'm going to stop sharing for a second because I'll need to share my entire screen, but I'm going to make sure I have everything set up okay. Alrighty, so now if I share my entire screen, entire screen. Oh, the ultimate mirror. Alrighty. So now I'll just, Camilo, can you still see my screen okay?
Yeah, I can see it.
Perfect, thank you so much. Okay, so great. So I'm using Visual Studio Code. It's the recommended one, but of course, maybe you're more used to something else. And also another quick thing before we jump into that is you can make sure that your Docker is open because you need it to be open. You don't need it to be running straight away. We'll do that with the AlgoKit command, but just make sure it's open so it's able to communicate. So now I'm in my my terminal. I'm just going to make a directory really quick called workshop demo.
Sarah, could you increase the font size, please,
yes.
so it's easier for us to see the commands that you are entering? Awesome.
Thank you so much for reminding me. Awesome. So I've just made a directory. You don't have to do this. I'm just doing this so it's nice and organized. After this, then I'm going to jump into that directory. And we're going to begin. So we're going to begin now. So if you're in your code space or if you're in your local environment, but don't worry, we have all the instructions as well. So what I'm going to do is, firstly, I'm going to run AlgoKit. And with this, you can see we get a big pop-up of what you're able to do at the AlgoKit command line. So we have compile, so you can compile smart contracts and smart signatures written in supported high-level language to a format deployable on the AVM. You have completions to install and uninstall AlgoKit shell integrations, configure to configure AlgoKit settings, dispenser, so you can interact with the AlgoKit testnet dispenser. So that's we're in the local net. But if you're working on testnet, you'd have to go to the web and get the dispenser. So of course, having it there makes it way easier. So that's maybe in the future. Then we have Doctor, which diagnose potential environment issues that may affect AlgoKit, which I was speaking about earlier. We have AlgoKit Explorer, which will take us to LoRa. We can look at all of our transactions with a super nice UI. We have Generate to generate code for an Algorand project. Goal. We also have Init, which we'll use to initialize a new project from a template. We have LocalNet, Project, and Task. Really quickly to show you AlgoKit Doctor. This will send you back what you're, if you have anything wrong. Thankfully, I have everything set up okay. If you're having any path issues, feel free to come to our Discord. So now, let's get into AlgoKit Init. So the first question asks, which of these options best describe the project you want to build? We just want to build a smart contract of a digital marketplace right now. But in Workshop 3, we'll be doing the front end, so make sure you register for that as well. A quick plug. So we have smart contracts. Which language? Well, we want to use Python. There is also TypeScript available, and soon that will be ready for production level apps as well. So we have Python. Then name the project or directory. I recommend for this to copy the exact same naming that I use, as it works with the code that has already been generated for you. So we're going to do digital underscore marketplace. So now it's starting up the template and rendering, and it asks us, hey, what do you want to call your smart contract application? So let's just call it our digital underscore marketplace. Next, is it a starter, production, or custom? Starter is obviously for prototyping, but let's just do production to make sure we have everything set up the way we want to, and to look at it more in whole. Next, what programming languages do you want to use for your contract deployment code? Once again, Python. And lastly, this is where it asks you, do you want to run Bootstrap, which will make sure you have all the dependencies you need. So we'll do yes. Only takes a moment, but it may take longer if it's like your first time using AlgoKit as well. Would you like to initialize the Git repository to perform an initial commit? Sure. So now we have it. So now what I'll do is I'll just open up the project. So if I go to workshop demo, I believe I called it. Don't mind all my pop-ups, but now we can see on the screen we have our workshop demo directory with our digital market directory. And in here we have our code, our workspace, which if you're going to run the code, you need to enter the workspace. So we'll quickly enter our workspace. Then inside of this, we have our root and our digital marketplace. This is for our backend. But of course, say if you chose the full stack option, you would have another directory here, which would be for the front end. But this is for the backend. So when we open this up, there's only two ones that we want to take a deep look at, which is smart contracts and tests. But for now, let's see what AlgoKit generated for us to start. So it generated for us a really cool hello world smart contract. So if we go to our command line again, and firstly, before you try to run any code, we need to make sure that our local net has started, because if we're going to run on the Algorand blockchain, we have to make sure that our private Algorand blockchain is there. So if we do AlgoKit, let's see if I can make this look a bit nicer. Alrighty. AlgoKit local net start. And now what this is doing, since I'm in my local environment and I have Docker, let's give it a moment. What I might do is really quickly just open and close my Docker again, because sometimes this happens, but not to worry at all. Just going to restart it. Okay, great. So as you can see, it can be a little bit iffy, but don't worry. All you need to do is either try start Docker again or use AlgoKit localnet reset as well. So it obviously failed to start the localnet, but that's okay because we'll just start it again. AlgoKit localnet reset. I'm just going to start a complete refresh. AlgoKit localnet reset. Alrighty, so now it's starting up our private blockchain. Perfect. So once this is all completely fine, great, we have it running. Let's have a look at running the template contract they give to us firstly. So we have AlgoKit project run build, because you can't deploy smart contract until it's built. So if we run this command, it will start to build. And you might have noticed on the left-hand side of my page, artifacts was generated. And if we look at artifacts, we can see our approval and clear, which we talked about earlier in the presentation, and our client, which is super nice. So now if we were to run this AlgoKit project run test, because it generates the test for the generated smart contract as well. And then we look at AlgoKit explore, the tests have passed. The more times we do this, the more times we get used to it as well. So if we go into here, we have our application call. We're not going to stay too long on this at all. But down here, it's kind of cool. We obviously have our hello world, which was called here. And one other thing, of course, because this is generated and all ready to use, we have this where you can build and deploy as well. So we have already built it, but just to show you what it looks like in the command line if we deploy the smart contract. And it also creates the applications, make sure everything's funded for what needs to be done, and it gets deployed, and it calls hello world. But anyway, that is the generated smart contract, but we obviously, we've done the digital smart contract. So if we go the digital marketplace, if we go back to our workshop, and I'll just, well, if I check the chat, it will go into the mirror effect. So please feel free to ask any questions and Camilla will help out. And what we're going to do is we're going to go to our code so we can copy and paste the digital smart contract for inside of our smart contract file. So if we grab this over here, we just copy and we go over here, and we paste it in. So if I was to just zoom out a little bit, you can see if we went into this straight away, maybe it wouldn't have been overwhelming, but I think it's better we went through it conceptually. But there is also, let's see the time. We're doing good on time. All right, so if we go through here, we can see obviously we have our imports. Assets are the native objects rather than the smart contracts. The global is used to access global variables from the network. Transaction is used to access information about the current transactions. uint64 was the data type of the 64-bit unsigned integer. We also have our arc4, the standard, our group transaction, which is used to read transactions within the same atomic group, specifically for this contract. And the inner transaction is used to send transactions from within a smart contract. Just going to move this over here. Then we obviously have our first method. We had our create application, which we worked on before, where we have the asset of the ID of the asset we're selling and the initial sale price. And then we save those values. We pass into our method into the contract state here. We have our set price method where we do a check that the sender is the creator address, because only the creator can set the price. And then we also have our unitary price that with the new set that we make it. Next, we have our opt-in, which is more Algorand specific. So before any account can receive an asset, it must opt into it. And this method enables the application to opt in to that asset. So whenever someone calls this method, they also need to send a payment. A payment transaction is a transfer of algo, since that is the native currency of Algorand. And we want to make sure that the application address is not already opted in. Then in the next one, just like asserting fields in transaction, we can assert fields in the payment transaction. We can do this only because it is grouped automatically with our app call, and because we made it an argument to the method, there's no guarantee that it is being sent to the application's address. So normally we need to manually assert. And assert, once again, just think of it like a check. Next, of course, Algorand has a minimum balance requirement. So we need to make sure that every account has a minimum balance requirement of 0.1, and any asset or more assets that they hold, they need to have a minimum balance requirement for that as well. So after that, we submit our inner transaction for the smart contract to opt in. Next, in our buy method, it's for a payment must be sent and the quantity of the assets to buy. So quantity and the payment. We have a few asserts there as well to check, to verify that payment is being sent to the application and there is enough to cover the cost of the asset. Lastly, once we verify the payment, we can transfer the asset. So this is a asset transfer inner transaction. And lastly, the delete application, which is to make sure that we get rid of any minimum balance requirements and assets that may have been left over, or any payments that have been kept into the smart contract. Okay, so now if we build out this new smart contract, because right now the one that has been built is our hello world. So if we go in here, and if I just quickly clear, we need to build out this new smart contract. To get the code, it was in our workshop to rise up, and at the very bottom there. So now, if we do AlgoKit project run build, this will build our new smart contract. And of course, if all the methods are correct, but of course the senior DevRel team, they have done this before, so this is all correctly built, we'll get a really nice green tick saying that Digital Marketplace was able to be built successfully. So now if we look again, we will see that these have been updated. Our approval, our clear, and our client. So the next thing we need to do, and what I like to do before going and running the test, which we need to change the code for, but I like to do an AlgoKit local net reset so we can just focus in on what's happening here and we won't get confused with the hello world transactions that happened before. So this is what I was saying earlier about completely resetting the blocks in our private network. And so AlgoKit local net. And before we do that, if you want to just check the status, like, oh, is my local net running, and you don't want to keep starting it all the time, you can just do AlgoKit local net status, and it will tell you if it's running or not. All of these commands are in the sheet that I shared, and also if you wanted to get used to the command line, I recommend going through and using like AlgoKit localnet, and then it will tell you what you're able to do with that. Start, status, stop, reset. So very handy. But let's just do a complete reset. Perfect. And now I'll clear that. And what we're going to do now is, I want to show you, I'm going to zoom out just one bit because it's quite zoomed in, but I'll zoom it back in a little bit. So we had our digital marketplace with our smart contracts, and we generated our artifacts folder thanks to AlgoKit. Now we have our tests folder, and inside this we have our tests, and we also have our client tests. Since we're going to be testing the client, it's for more consistency of coding, we'll do it inside here. Now it doesn't necessarily matter, but of course it's always good to have clean code etiquette. Because this is all worked out to work with the Hello World one, you will have to clear one of them. So if you go into our digital marketplace _test, now you can delete it, or you can just simply clear all of the code in there and save the file to make sure it's acknowledged. In our client one, what we're going to do is, if we go over to our sheet, once again, the reason why we're not doing this line by line is that it's already been done. It's on the Algo Devs YouTube channel, so 100% check it out there. The senior DevRel team went through it very comprehensively. So if we take this code now, and this basically runs the test for if every method inside of our smart contract is working correctly. So it's important to test. So now, if I just clear this, I'm going to move this over, we just paste in our tests. Now, what I did is at the very top of it, I thought it'd be handy for you to see what exactly these tests are doing, especially if you're not used to testing. So in this digital marketplace smart contract, we'll be doing account funding. As you know, every account needs a minimum balance requirement to be able to do anything. So we'll use the dispenser funds to fund both the creator and buyer accounts with Algo for testing purposes. You may have remembered in the first workshop, we have gone through how to generate accounts, fund accounts, create assets, group transactions, all of that. So some of this will look familiar to you, which is really, really good. Next is our asset creation. So the creator account creates a new asset with a total supply of 10 units. So that's the second test. In our third test, we'll do an app opt-in to asset. So the smart contract application opt-in to hold the created asset after receiving Algo to cover the minimum balance requirement. Next, in step 4, we have our asset transfer to app. So the creator transfers 3 units of the asset to the smart contract application. Next, we have the set asset price. So the smart contract sets a unitary price of 3.3 Algo for the asset. Now, this is just what we chose for the test. It can be, of course, any number. Then we have our buyer opt-in and purchase. The buyer opts into the asset and purchases 2 units from the smart contract by transferring 6.6 Algo. And lastly, we have our application deletion, where the smart contract is deleted and any unsold assets and remaining algo are returned to the creator account. And just for the purpose of, well, I'll go through this as well. We have our imports. This one may look familiar to you. We used it in workshop 1. And in this part, this is why I mentioned to call it a digital marketplace to suit the code. If you called it something else and you try to run this, you may have some issues. You'll need to put your relative path, starting from the smart contracts, where you find our digital marketplace client. That's where we're using the client tests, which you can find inside of your artifacts folder here in your digital marketplace client. Okay, so first we have our fixture to create an Algorand client that connects to the local test network. And this gets an Algorand client to use throughout the tests. So we're returning the Algorand client with the default local net here. Next, we have the fixture to get the dispenser account to fund the test tokens. So we need to get the algorand.account.dispenser to fund the test account. So we're returning the dispenser account so we can use it, as well as the address and signer. So we're able to sign those transactions. Luckily, it's within localnet, so the KMD can easily grab what we need. Next, we have a fixture to create a random account for the creator and fund it with algo. Just like we've done before, we do algorand.account.random, and we fund the newly created account with 10 algo from the dispenser with our algorand.send.payment and our pay params. And of course, we return that account. Next, we have a fixture to create a test asset using the creator account, where we create an asset with a total supply of 10 units, which is here, where we create an asset. And then we have to return that asset ID after the transaction is confirmed. So here we have our sent transaction, which looks at our transaction and it extracts the confirmation and the asset ID index of it to get the asset ID. Next, we have our fixture to instantiate the digital marketplace smart contract client, which happens here. And this instantiated an application client we can use for our tests. Lastly, we deploy the marketplace smart contract on the network, where we set our we set with our unitary price and our asset ID to work with our smart contract. Okay, so now if we go into the actual tests, this is all for setting up and making sure we have the accounts and everything we need and that the contract's deployed. So our first test is to ensure the application can opt into the asset, hence test opt into asset. We have to ensure the app has not yet opted into the asset, and if it can raise an error if it hasn't. Next, we send 200 micro algo to the app to cover the minimum balance requirement. Looks like 200,000, but it in reality is 0.2 algo. And we can see that here. Next, we have the app opt into the asset, as well as the asset ID must be declared for the AVM to use it. Once again, not going to go too deep inside of this code as it's already been done before and is on our YouTube channel. But just to go over it for the context, we ensure the transaction is confirmed in a round, and we verify that the app has opted into the asset, but doesn't hold any yet. The next test we're going to do is a test to transfer assets to this smart contract app, where we send 3 units of the asset from the creator to the app, which you can see here. We ensure that the transfer transaction was successful, and we verify that the app now holds 3 units of the asset. So verify or checks, that's how you can remember if cert. Next, we have the test set price to check if we can set the price of the assets within the smart contract. So in this test, we set the unitary price to 3.3 algo, which is 3.3 million micro algo. And then we ensure or re-verify that the price setting transaction was confirmed. Next, we test to simulate a buyer purchasing assets from the app. We create a new random account to act as a buyer. We fund the buyer account with 10 algo using the dispenser. We opt the buyer into the asset, and we form a payment transaction from the buyer to purchase 2 units of the asset, which you can see here. Next, we execute the buy operation on the app. We inform that the AVM that the transaction uses this asset, and we make a few asserts as well to verify. This one is to verify that the buyer now holds 2 units of the asset. Lastly, our last test before we run it and look through it in LoRa. So I really appreciate your patience and also your attention to this as well. Hope it's been really meaningful. But this last one is the test to delete the application and retrieve the remaining assets and funds. We get the balance of the creator before the app is deleted. We set the custom transaction parameters for the deletion. And then we delete the application, ensure the deleted transaction was confirmed in a round. We get the balance of the creator after the app is deleted. And we verify the creator received the remaining funds of unsold assets. So essentially, the creator should receive everything that was put into it. We're going to get rid of anything that's inside of that smart contract. To show the test, I'd like to just, now you don't have to do this one, but I'm just going to show something on LoRa. So I'm just going to comment that out for now, but I'll go back and I'll uncomment it to show you what it's like deleted as well. But now we have our tests. Let's go back to our command line. So just for best practice, let's just check that our local net's still running well. Very nice. At this point, just to double check AlgoKit root project, bootstrap all. Let's just make sure we have all the dependencies installed. Great, it's already was done. But if you're having any issues, I recommend double checking your local net and making sure your dependencies are installed. It doesn't mean the logic of the code is necessarily wrong. All right, so now what we need to do, we've already built out our smart contract. So all we need to do now is run our tests. To do this, we have AlgoKit project run test. And if we're lucky, yay, it worked. So we have 4 pass. We obviously have the 5 tests, but we commented that last one out for the purpose of showing something in LoRa. So to go to LoRa, we do AlgoKit explore. This will pop up a new tab for us, and it's beautiful, beautiful UI, nice and colorful. And let me zoom in actually. So we have 9 blocks. So let's go through those 9 blocks for the moment. So in this first one, we see we have a payment from one address to another. This is the dispenser address sending 10 algo to our generated account. So it has some algos to play with. Next, in block 2, we have an asset configuration. So this is where we have an asset create, where we create the asset ID 1002 with a total supply of 10. Next, in block 3, we have an application call. This is where we have created our application, which is application ID 1003. And by the way, if you keep creating applications, they'll come up with new asset IDs, of course. Now we have our 3 transactions. And inside here, we have some inner transactions. So if we look at our group ID, we can see really nice UI to help explain what's happening. We do a minimum balance requirement payment of 0.2 algo, and we make an app call. This then triggers the smart contract to opt into the asset, as we can see down here in the pink. Next, in block 5, we have an asset transfer where we send from our where we created our assets. we send 3 of those units, as we stated in our test, to the application address. Next, in block 6, we have an application call, which is where we set the price of the unitary price. So if you see here, we go to our global state. Like we went in the presentation, global state is seen by everyone. So we have our unitary price set to 3.3 algo. In block 7, we have a payment type transaction where we send from our dispenser account to the receiver account we created to make sure it's funded. Then in block 8, we have an asset transfer, which you can probably guess already, it's an opt-in for our receiver account because it needs to opt in before it can receive the asset. In our 9th block, we have some inner transactions as well. And also to make note, you can see exactly what it is up here. You don't have to necessarily click in, but just because it looks really cool. So we make a payment of 6.6. So that's the receiver account buying these assets from the smart contract, from the digital marketplace, makes the app call, which triggers, once we make those asserts and we verify, yes, this is all correct, it transfers 2 of those assets to the receiver account who bought. And there was something I wanted to point out here. Inside of our application ID, this is our application, we have 2 global states, the asset ID and the unitary price. Sorry, which we can see the value and the set. But now, really quickly, I just want to go back to the code, and I'd like to uncomment this out, because this is where we delete it. I'm going to really quickly AlgoKit localnet reset just to keep it nice and simple. We're going to clear it all again. And this will essentially give us block 10 where we delete the application. So hopefully that works in a moment. I've been messing with the localnet quite a bit. Fantastic. Nice. So now we uncommented that out, or maybe you've already done this this test. But now we'll do AlgoKit project. We don't need to build a smart contract again, as this was just inside of the test. AlgoKit project run test. So this has the 5 passed. If you're having any issues, it's probably the localnet or the dependencies. So the commands are in the other sheet to make sure you have that all perfectly fine. But you can also message me anytime after the workshop. I'm very happy to help if I can. If I can't, I'll lead you to the Discord. So now we have, we're going to look at it in LoRa. So if we do AlgoKit explore, it will give us our new one. Let me just X off those. So now you can see we have a new one that was not there before. This is where we basically make an app call. It checks a few things, and it has it basically is transferring everything out of that smart contract. It transfers whatever may be there or the remainders, and the same with the payments. So that's for algo then. So any of the payments, and it takes away all the remainders that's there. Then you'll notice, this is why I wanted to do this before. I wanted to comment this method out before, or this test, is up here we have deleted. And if we notice, before we had the global state that showed our unitary price and our asset ID, but now we have nothing in there. So this is essentially going through the smart contract, the digital marketplace smart contract, where we planned it from the whiteboard, and then we ran it, the code, built it, and we also then ran the tests for it, and looking at what really happens with inside of LoRa. Now, if you did want to know line by line everything that's happening and you wanted to build it out, the AlgoDevs YouTube channel has everything you need. Those exact bootcamp videos are there. So if you're looking for that, I recommend it. But yeah, I guess this is the moment. Wait, let me really quickly, I'll go back to the presentation. Go back over here. Okay, perfect. So we planned a smart contract. We coded with Python using AlgoKit, and now I guess it's time for you to, if you're doing the hackathon, start building solutions at scale with AlgoKit. So I guess we'll open it up now, Camillo, to maybe some questions. I know this was quite a information intensive possible deep dive into smart contracts on Algorand. But yeah, I hope everyone found this session meaningful. But yeah.
Yeah, so, Sarah, thank you so much. And maybe the first time that we try to create our own smart contract, we feel that there are a lot of things to understand. You don't know where to start. But with AlgoKit, for sure, we can set up our project in less than 1 minute. And today's session was a bit different because, as you mentioned, the content about how to create the smart contract is already in our YouTube channel. But we realized that it was good to add an additional explanation about the methods, about how you can start planning your own smart contract. And then after this session, you can go directly to our YouTube channel. I share the links in the chat, and you can watch the full explanation line by line. But the important thing is how you can use the things that you just explained to us for create your own project. And with the digital marketplace smart contract, you will have all the things to store information in global state. You will create methods to buy assets. You will create methods to do opt-in to specific functionalities. So in that smart contract, you can find almost all the things that you can use for create your own solution. So we don't have enough questions. There are super good comments on the chat. And this session is the preparation session for the hackathons, but also for all the algo devs that they want to keep building and keep learning about Algorand. I love Python, so for me, be able to create a smart contract using Python is the best. But in the session 3, this is a reminder, you will learn how you can create the front end that can interact with this smart contract, because that is the important part, how you can create a user interface that is interacting with this smart contract. I don't know, Sarah, if you have anything else to add.
I think I've been chatting enough. I'm sure they're tired of hearing my voice. So I think it's all good from me. I'm just really excited to see you guys in workshop 3. And there was a quick question there. What language will you use for front-end interface? So I believe AlgoKit generates, when you do the full stack generation, it generates it for React. But you can use, with AlgoKit, it's agnostic framework. So you can take that away and use whatever you like as well. So there's lots of flexibility.
Yeah, but to answer that specific question, we are going to use TypeScript. And I know that we are working on creating more content about how you can use flags, for example, if you are just coding with Python. But for the next session, we're going to use TypeScript. All right. So, AlgoFam, thanks so much for joining us, and looking forward to see you in the next session. Anything else, Ara, that you want to share with us before we end today's session?
No, just thank you so much again for your time and patience. I know it was quite a long session, but hopefully I'll see you in the Discord or on the AlgoDev's Twitter timeline.
Yeah, and maybe, I don't know if you already add the Miro in the Rise, but maybe we can add the Miro so all the AlgoFan can take a look of the Miro for them to keep understanding the way that this smart contract is working. Okay, guys, thank you so much, and see you the next week.